Hello, everybody. Today in 6.6, what we're going to do is we're going to start solving word problems. So we're basically going to be applying all of the skills we learned in the previous lessons to solve different types of word problems. We'll start off with this first one. We'll just jump right into it. When I read a word problem, my strategy is I read the problem once, just because it's kind of going to freak me out, in all honesty. So I'm going to read it, get confused, and then I'm going to just relax. I'm going to read it again, and then I'm going to try to build the equation, so turn the words into letters and numbers as I read the question. So it says, a number is doubled and decreased by 6 to obtain 66. Determine the number. All right, that's freaky, right? You read that, you're like, I have no idea what the number is. But if we look back and we slowly build the equation as we read it, it might make it a little bit easier. So it says a number. If we don't know what the number is, which in this case we don't, it just says a number, we call that x, right? We make it a variable. So it says a number, x, is doubled. That means it's multiplied by 2. So now I have 2x. And decreased by 6. Decreased means subtraction. So this is subtracted by 6. To obtain means equals 66. So if you read the question slowly and you build it as you read it, you'll find that you can actually create equations pretty easily. But if you read it all at once and try to think of the question holistically, it's too challenging. You have to break it down into its steps. At that point, I like to usually just rewrite the equation a little nicer. We have 2x minus 6 equals 66, and then I try to solve it. So to solve, I'm going to add 6 to the other side. That gives me 2x equals 72. I'm going to divide both sides by 2. At this point in the unit, I'm going to go pretty quick when I'm solving. If you're struggling with understanding how I'm solving, then you should probably go back and practice the previous units. If you can't keep up with me solving, that's fine. I'm probably going faster than you can, and that's all right, as long as you understand what I'm doing and can follow along with what's going on. The main purpose of this lesson is working with word problems, not the actual solving part. At least not early on. It gets a little harder later. So we look at B. My plan, read it once, read it twice, and then work it out as I'm reading it the second time. When a number is divided by 3 is added to 15, the result is 22. Determine the number. Okay, let's start this. When a number, we don't know what the number is, so we have x, is divided by 3. So we now have x divided by 3, like that. When a number is divided by 3, is added to 15, so it's added to 15, so technically I should probably put the plus sign here, added to 15. The result means equals 22. So you'll see I try to color code it somewhat when I'm breaking it down, but if I read this, it says when a number, I have x, is divided by 3, so I put divide by 3 in green, is added to 15, so I added it to the number 15. The result means equals 22. Again, I usually just like to rewrite it a little nicer after I've made it, and then I start solving. To solve, the first thing I need to move is any additions or subtractions, so I need to move that 15 to the other side. That leaves me with x over 3 equals 7. Then I have to get rid of that divide by 3, so I multiply both sides by 3. That leaves me with x equals 21. Wonderful. C is a little bit trickier because we're going to actually get two numbers. So if you read the question, it says the sum of two numbers is 46. One number is 12 more than the other. What are the numbers? Okay, in a question where you have two numbers that you don't know, two numbers means we must have two equations. Typically, the first sentence will create the first equation, the second sentence will create the second equation. If there was three numbers, we would need three equations, four numbers, four equations, and so on and so forth. So the first sentence is right here. That should make my first equation. So if I read it again, it says the sum of two numbers. Sum means addition, so sum of two numbers. I don't know what they are, so I call it x and y. I can't call it x and x because that would be the sum of the same number, right? This is the sum of two numbers, so that means they're different numbers. They're x and they're y. is means equals 46. This first equation is coming from this first sentence. Because I have two letters, I have x and y, that means I should have two equations. So I notice that the second sentence over here should create the second equation for me. When I read this one, it says one number, so we don't know which one. We're just going to say x. One number, x, is means equals. Every equation should have an equal sign somewhere. So one number is 12 more. 12 more would be 12 plus. Right? If I'm adding, if I have more of something, that's adding. Is 12 more than the other. So 12 more than the other number being y. So this equation came from this one. Awesome. Again, I like to just rewrite these things out a little neater. So I have my first one. I have x plus y equals 46. And my second one is x equals 12 plus y. Beautiful. This is called technically a systems of equations. So this is when you have two different equations and you're trying to solve for two different numbers in those two different equations. You can't solve with, if there's two letters in one equation, you can't solve unless you can get rid of one of those letters and turn it into the other thing. So like, for instance, if I looked at this first equation right here, x plus y equals 46, I could never solve that by itself because I could never get x and y both by themselves, right? They're always going to be x equals something y or y equals something x. And then you're never actually going to know because they're always going to be bouncing back and forth off each other. So what we have to do is somehow connect these two equations. And the way that we do that is we look for the equation that already has one letter by itself. In this case, I have x equals 12 plus y. What that means I can do is I can take x equals 12 plus y and I can substitute it into the other equation for x. So if this x equals 12 plus y, then this x should also equal 12 plus y. And it's called substituting. So I'm going to substitute this first x to make it 12 plus y. And when I do that substitution, I put it in brackets. I then leave everything else in that equation the same. So if you're looking, what I've done is I've looked at the second equation, realized that x equals 12 plus y, and I've now changed the other x to become 12 plus y. What this does is it creates an equation where I now only have one letter. And if I look at this system right here, all I have now is y's. All the x's are gone because I've changed them into y's. So I just need to solve that equation. To solve that equation, I have to get rid of the brackets. That means I have to multiply whatever's right in front of it into the brackets. In this case, it's just an invisible 1. Nothing actually changes. So this becomes 12 plus y equals 46. I then collect like terms. I have a plus y and a plus y. That would become 2y. So I have 12 plus 2y equals 46. I can subtract the 12 to the other side. That gives me 2y equals 34. And then I can divide both sides by 2 to get my first letter of y equals 17. Awesome. Now, we've only solved one of the letters. We know that there's two letters in this question, right? There's x and y. The only thing we have figured out is that y equals 17. To get my second answer, what I do is I take this information of y equals 17 and I put it back into one of the other equations. In this case, I'm going to be able to put it into this equation. So this said that x equals 12 plus y. That means I can actually change this to be x equals 12 plus 17. Since I know that y is now 17, that gives me my second answer of x equals 29. So my two numbers are y equals 17 and x equals 29. Now, technically, you could have done this question and gotten y equals 29, x equals 17, and that's fine. You just labeled your question different than I did. The question said, what are the numbers? The numbers are 17 and 29. The letters that you choose to represent those numbers don't actually matter. So the answer is 17 and 29. Okay, I understand that's very challenging. That's very hard. We'll do a couple more system of equations, but those are definitely the higher level word problems and definitely something that we practice more and more and more in grade 10 as well. So if we look at question D, we're going to read it once. We're going to get a little overwhelmed by it. Then we're going to read it a second time, and we're going to build equations as we read. So this says one number is 5 more than another number. 3 times the smaller plus twice the larger is 30. Find the numbers. Okay. First sentence creates my first equation. It says one number is 5 more than another number. One number is x. Is means equals. 5 more means 5 plus another number. So x equals 5 plus y. If I read the second equation, 3 times the smaller plus twice the larger is 30. Wait, 3 times. I know how to do that. That's 3 times. The smaller number, though, is tricky. So we have to ask ourselves which one of these values is smaller, x or y. And if you think about it and you look back at this equation over here, if y was equal to, say, 10, then x would be 5 more, so x would be 15. If y was 20, x would be 5 more, so x would be 25. So the smaller number is always going to be y. So when we look at this equation and it says 3 times the smaller, we know that the smaller is y. 3 times the smaller, plus means addition. Twice means 2 times. The larger, which we now know as x. Is means equals 30. We now have our second equation. Our second equation is 3y plus 2x equals 30. I'm not sure if building the equation on top of the words helped you or not, but I figured I'd try it and see if you like it or not. I had 2 different sentences. I have 2 missing letters. So that means I have 2 equations, which I have, right? I have a red equation and a blue equation. My goal is to somehow substitute one of the equations into the other. If I look at the first one, I notice that it says x equals 5 plus y. That means that this x should also equal 5 plus y. So I can substitute it in over there, making my blue equation now 3y plus 2. And then instead of x, I'm going 5 plus y. And then equals 30. So that's the substitution step, right? I take one equation and I put it into the other equation. I then have to solve this equation, the one I just created. I solve it by getting rid of the brackets. So I'm going to have to multiply the 2 into the brackets. That will give me 3y plus 10 plus 2y equals 30. I then can collect my like terms. That'll give me 5y plus 10 equals 30. I then want to subtract my 10 over. That gives me 5y equals 20. And then I want to divide both sides by 5. Giving me a final answer of y equals 4. We've successfully figured out one of the numbers, right? In this case, we figured out the smaller number. We figured out y equals 4. I use that answer and I put it back into one of my equations so I can solve the missing second number. In this case, it's now 5 plus 4 instead of 5 plus y, meaning that x equals 9. My two numbers are 4 and 9. Wonderful. I understand that's very, very challenging. You might need to watch that a few times and pause and rewind at different moments to be like, whoa, what's going on? And that's fully expected. If we look at E, E is a tricky one. You might want to try it on your own. So maybe this is a good time to pause and just try one on your own and see if you can build the equations. I suggest that you try building the equations, then you check to see if you have the right equations built, and then you pause the video again, and then you solve the equation. There's nothing worse than building the wrong equation and then solving the wrong equation. Then you just feel like you've wasted your time. So if you want to pause right now, see if you can build the two equations. That's all you should be trying to do. Awesome. Hopefully you paused and came back and you read this question. You said, I'm thinking of two numbers. The second number is 9 more than 5 times the first number. The sum of the two numbers is 75. What are the two numbers? I read it once and I have no idea what the two numbers are. Right? Like guessing and checking is not going to be the method. Remember that tests are timed for a reason because you could guess and check these answers all day and eventually find two numbers that make this work. So you have to have a mathematical approach. That approach is that we're going to read the question a second time and we're going to build equations as we read them. So it says, I'm thinking of two numbers. I'm just going to say x and y. The second number, we don't know what the second number is. I'm just going to say it's y. The second number, y. Is means equals. 9 more means 9 plus. Then 5 times the first number. So 5 times the first number, which is x. I just built an equation from that first sentence. The second number is 9 more than 5 times the first number. If you have it as this, if you put x equals 9 plus 5y, you're also correct. That's fine. You're just saying that x is the second number and y is the first number, and that's fine. Okay, the second sentence, in this case, it's actually the third sentence, but the second one talking about math should build our second equation. So it says the sum. Sum means addition of my two numbers. So my sum of x and y is 75. There we go. We've successfully built our two equations. I suggest that you pause right now and see if you can remember how to solve this. So now that you have the proper equations, hopefully you already had the proper equations, but now that you do, for sure, you can go ahead and try to solve this. Wonderful. Solving this. What I need to do is realize that this y and this y are the same thing. So if the first y in red equals 9 plus 5x, that means the second y must also equal 9 plus 5x. So I can substitute it or change that y to be 9 plus 5x, like that. And then equals 75. Whenever I do that swap, that substitution, I always put brackets around what I substitute. And then I do have to get rid of those brackets. In this case, there's an invisible 1 in front of the brackets. So I just have to multiply that invisible 1 in. It's not going to do anything, but it's going to get rid of the brackets. So it still stays as 9 and 5x, like that. I then have some like terms here. I have x and 5x. That'll add together to be 6x plus 9 equals 75. I want to subtract my 9 from both sides. That gives me 6x equals 66. And then divide both sides by 6. That gives me x equals 11. Beautiful. Once I know one number, I can substitute that answer back into one of the original questions to figure out the second number. So this would now become y equals 9 plus 5, and then instead of x, I'm putting in brackets 11. That means y equals 9 plus 55. If I did 5 times 11, that means y equals 64. So my two numbers that this person was thinking of are 11 and 64. Hopefully you got that right. If you didn't, that's okay. This is really hard. Probably the hardest thing we're going to do this whole unit, my opinion. So that's okay if you got lost. Just keep trying your best, right? That's all you can do with these word problems is try to do a mathematical approach and just try. You keep practicing until you get good at it. All right, F says I'm thinking of three numbers. So now we're going to have three equations because there's three numbers. I'm going to call these numbers X, Y, Z. First part, the second number is twice the first. So if I'm building that slowly, the second number is Y, is means equals, twice is 2 times, and the first number I'm going to call X. The next part creates the next sentence. And the third number is 4 more than the second number. So the third number is Z. Is means equals. 4 more means 4 plus the second number, which is Y. My last equation is my last sentence. It says the sum of three numbers is 84. So if I'm building that, the sum means I have addition. The three numbers, so that's X plus Y plus Z, is means equals 84. And now I actually have three equations with three different letters built. I'm going to have to do a lot of substitutions in this one. If you notice, if you look at the first couple equations, the first one has Y all by itself. So that's nice. The second one has Z all by itself. So that's nice. So what we're going to do is we're going to slowly build our way up until we get all the way to the orange equation and we've gotten rid of all the letters except for one. The way I do that is by substituting. So I'm going to take this 2 times X and I'm going to substitute it into the green equation for Y. That'll change Z to be Z equals 4 plus 2X. And now what I can do is I have Y in terms of X and I have Z with term equals X. I can make both of those substitutions into the orange equation. So I'm going to do this substitution again, the Y equals 2X, but this time I'm going to put it all the way into the orange equation. And then I'm also going to substitute this green one, Z equals 4 plus 2X, into the orange one up there. Like that. When I substitute, I use brackets. So this orange equation is going to become X plus, instead of Y, it is now 2X. Instead of Z, it is now plus 4 plus 2X. And that equals 84. Sorry, I ran out of space a little bit over there. It's very small. And what I've successfully done is I've taken that orange equation and changed all the letters to be the letters X. Notice that I only have X's left in that far right equation. That means I can then start to solve that far right equation. First thing I have to do is get rid of the brackets. There's invisible ones in front of those brackets. So I can just multiply those things in. It's basically going to stay the same. So it's going to be X plus 2X plus 4 plus 2X. So nothing changed. The brackets just went away. Then I can collect like terms. I have a whole bunch of X's. So that's 5X plus 4 equals 84. I can subtract 4 from both sides. That gives me 5X equals 80. And I can divide both sides by 5. Giving me my first answer of X equals whatever 80 divided by 5 is. My brain's not working right now. 16. Now that I've solved one of my letters, I can use that letter to figure out the other two by substituting it back into these equations. We'll do the blue one first. So this now changes to be y equals 2 times 16. That means y equals 32. If I do the green one next, it's z equals 4 plus 2, and instead of x, I put 16. That means z equals 4 plus 32. That means z equals 36. My three numbers are 16, 32, and 36. That is the hardest question, in my opinion, that you guys are going to see. That's three equations, three unknowns, or three variables. That's super hard. So if that one was like way over your head, that's okay. That would probably be one of the hardest questions you'd see this year, in my opinion. Okay. At this point, if this is a very long lesson, okay, so these word problems, they just take a long time. I like to really be thorough and talk for quite a while, so maybe that's my fault. I suggest that maybe you take a little break. We're going to change gears a little bit to see some different types of word problems, and you're probably going to want your brain to be fresh. So maybe just like go take a break, go read a book, go for a walk around the house. Don't go to a friend's house because we're all quarantined still. If you're listening to this in like the year 2022, this was recorded during the whole COVID thing, so that we're all in quarantine. It's sad. Okay, so go take a break of some sort. Go get a snack. Go do something. Get your mind fresh, and then come back and maybe start the video again from here. Okay, hopefully you did that, and hopefully you took a break. This next part of word problems, we're going to do something called consecutive integers. Consecutive is like in a row. Integers are numbers. So an example of three consecutive integers, that's three numbers in a row. So for instance, like 2, 3, 4 are called consecutive integers, right? It's numbers that go in a row. Algebraically, the way that we represent them, so algebraically, is we say that the first number is x. The second number would then be the same number, x, but plus 1. Right? That's how I would get to the next number in line. And then if I wanted to get to the third number in line, it would be x, which was the first number, and then just plus 2. These are consecutive integers, right? They mean the same thing. It's three numbers that would all be in a row. If we wanted to do consecutive even integers, so consecutive means in a row, even numbers is what integers means. That would be like 2, 4, 6. So to represent consecutive even integers as algebraic numbers, I would say the first number is x. The second number, if I wanted to get from the first to the second, I would have to do x, which is the first number, plus 2 more. And if I want to get to the third number, it would be x plus 4. Right? If you think about it, x is 2. The next number that's even consecutive would be 2 plus 2, which is 4. If I want to get to the third one, it would be 2 plus 4, which is 6. Awesome. We're going to use some of those definitions to solve some word problems. So this says, the sum of three consecutive integers. We don't know what these consecutive integers are, but we know that these three consecutive integers can be represented by x, x plus 1, and x plus 2. So I want to create an equation that is the sum of those three things. So the sum of them would be x plus 2 plus, oh, sorry, it's going too fast. X plus 1 plus x plus 2. And these are our three consecutive integers, right? X plus 1 plus x plus 2. Is means equals 126. What are the integers? Awesome. If I want to solve this, I'm looking at my equation. I have one letter. I need to collect my like terms. My like terms here, I have 1, 2, 3 x's. And then I have 2 plus 3 is 3. So I have 3x plus 3 equals 126. I could then solve this by moving the 3 over. That gives me 3x equals 123. And then I divide both sides by 3, which should be a nice even number. 123 divided by 3 is 41. So x equals 41. Now, that's not the answer, right? That just tells me what my first consecutive number was. To figure out the other ones, if they're consecutive, that means my answer is 41, then it's 42, then it's 43. That's my answer. The three numbers are 41, 42, 43. Awesome. Let's look at D. It says find 3 consecutive even integers. So when you read that, 3 consecutive even integers, that means you have one number, another one, which is x plus 2, and another one, which is x plus 4. So find 3 consecutive even integers such that the sum of twice the first and 3 times the third is 172. That is intense. So when you read something that's that confusing, build it as you read it. So we're going to try again. The sum means addition of twice the first. My first number was x, so twice the first is 2x. And 3 times the third. The third number was x plus 4, so it's 3 times x plus 4 is 172. That's how you would make that equation. Now your job is to solve that equation. We're going to solve that by getting rid of the bracket, so we have to multiply n. That gives me 2x plus 3x plus 12 equals 172. I then want to collect my like terms, so that would become 5x plus 12 equals 172. I'm going to subtract 12 from both sides. That gives me 5x equals 160. And I divide both sides by 5. It should get you 32. X equals 32 is not the answer. The question was find the 3 even consecutive integers. I found x is 32. That's the first of my even integers, right? X is the first one. So that means my answer is 32. The next even consecutive integer would be 34. The next even consecutive integer would be 36. My three numbers are 32, 34, and 36. If you tried guessing and checking to solve, you could get it, but it would take you forever. I promise you that. I've seen people try. It will take them the entire test just to try to solve that one question. You need to find a way to create math out of words. Beautiful. We're going to try some money questions here. So if we have money, we are going to try to build equations as we read sentences again. So this says, Joe has twice as many dimes as nickels. The value is 350. How many nickels does she have? Okay. First sentence should create the first equation. Joe has twice as many dimes as nickels. Okay. How many dimes does she have? And how many nickels does she have? In this case, we don't know, right? So what we have to say is that x is the number of dimes and y is the number of nickels. Not the value of them, but how many she has. So now I can actually build an equation out of this first sentence. Joe has twice as many dimes as nickels. That means if you took the number of nickels she has, which is y, she would have twice as many dimes. So you'd have to multiply that by 2, and that would tell you how many dimes she has. That represents twice as many dimes as nickels. I'd have to take the number of nickels, y, and multiply it by 2 to figure out how many dimes she has, which is x. All right, second sentence. The total value is $350. That's tricky. To do that, if you wanted to figure out how much money you had, you would take the number of dimes you have, which is x, and you would multiply it by the value of a dime, which is 0.1. Then you would add how much money you have in nickels. You have y nickels, and you times that by the value of a nickel, which is 0.05. And that total should be $3.50. This is another very challenging question. I'm going to run out of room here. I can already sense it. So I'm going to try to move this up a little bit. To solve this now, I have two equations. We know that when we have two equations, we have to try to take one of them and turn it into the other one. So I'm going to take this first one that says y equals x. And I say, okay, if x equals 2y, then this x should also equal 2y. And I'm going to substitute that in there. So my new equation would be 2y and then times 0.1. And then plus, instead of writing y times 0.05, I'm going to reorder it to be 0.05y equals 350. We've talked about that reordering thing before, right? In multiplication, you can reverse the way that they're written. I just like the number in front. That's kind of more the proper way to do it. I now want to get rid of my brackets. I'm going to do that by multiplying the 0.1 against the 2. So if I go 0.1 times 2, 0.1 times 2, that gives me 0.2. So I have 0.2y plus 0.05y equals $3.50. These are now like terms. They're just decimal-like terms. So if I was to add them together, that would be 0.25y's equals $3.50. And then I'm going to divide both sides by 0.25. That gives me, if I go 3.5 divided by 0.25, that gives me y equals 14. Awesome. Y equals 14 is the number of nickels. The question said, how many nickels does she have? The answer is she has 14 nickels. If you wanted to figure out how many dimes she has, it says she has twice as many dimes. So if you doubled that, if you went 14 times 2, that would tell you how many dimes she has. But the question only wanted to know how many nickels there are, so the answer is 14. These word problems with money are very hard also. So again, just keep practicing and try your best to understand them. All right, B. Dan has $425 in his wallet. The number of 5s exceeds the number of 20s by 5. How many, I should say many, how many $5 and $20 bills does Dan have? Okay. We don't know how many $5 bills they have. So I'm going to say X equals $5 bills, Y equals $20 bills. So I gave you a letter to represent how many of each. We'll start with the first sentence, which doesn't look like it tells us much, but it does. It says Dan has $425 in his wallet. I can actually turn that into a mathematical equation. So if I wanted to calculate how much money he had, I would take the number of $5 bills he has and times it by 5. So 5 times X represents how much money he has in $5 bills. Then I would add how much money he has in $20 bills. That would be $20 times the number of 20s, which is Y. And that should equal $425. Right? That's how I count money. I figure out how many 5s I have, or how much money I have in 5s, and then I figure out how much money I have in 20s, and I add the two numbers together. The second sentence is going to create my second equation. The number of 5s, so number of 5s, that's X, exceeds the number of 20s by 5. That means that if you had x, it would equal the number of 20s, which is y, plus 5 more. That represents that he has 5 more 5s than 20s. You then can solve this equation by substituting the second thing into the first thing. If this x is y plus 5, then this x should also be y plus 5. I can change that by using brackets. So this x becomes y plus 5, like that. Everything else in the red equation stays the same. I then need to solve this by multiplying into the brackets. That gives me 5y plus 25 plus 20y equals 425. I should have some like terms, which I do. That gives me 25y plus 25 equals 425. I'm going to subtract the 25 over. When I subtract the 25 over, I'm going to rework over here, like reorganize. That gives me 25y equals 400. And then I divide both sides by 25. When I do that, I should get y equals, I think it's 16, but I'm going to double check because my brain has been off today. So we're going to say y equals 16. That means the number of $20 bills he has is 16. If you wanted to figure out how many $5 bills he has, you could take this information and substitute it back into this equation right here. That equation said x equaled y, which is 16, plus 5. That means x equals 21. He has 21 $5 bills. My answers are over here just because I ran out of room. So that's my solution. I understand that this is hard, and the algebraic process, I'm going fast. So like for instance, once I have those equations set up and I do my substitution, I solve that red equation very, very fast. You don't have to be able to solve that fast. But you should practice until you understand what I was doing. If you can understand what I'm doing, then you're good. The solving practice was back in 6.5, 6.4, 6.3, right? That's where you should go practice solving if you don't remember how I'm doing it. Okay. We have 2 more money problems. So I have a total of $9 in dimes and nickels. Again, when they tell you a total, they're actually giving you an equation. So I have a total of $9 in dimes and nickels. I don't know how many nickels I have. I'm just going to say x equals nickels and y equals dimes. So if I have a total of $9, that means 9 should actually, let's do the money first. If I wanted to count my money, it would be 0.1 times y plus 0.05 times x. That represents how much money I have in dimes plus how much money I have in nickels. That should equal $9. The next sentence should create the next equation. So if I read my next equation, it says the number of dimes, that's x, that I have is 10 more than twice the number of nickels. So if we try to build that, the number of dimes I have, dimes was y. I think I just said it was x, but it's y. The number of dimes I have means equals, 10 more would be 10 plus, twice the number of nickels, 2x. That represents the number of dimes that I have is 10 more than twice the nickels, 10 plus 2x. I then can solve this, right? So I'm going to substitute this y into here. Again, I'm going to run out of space probably. So this will give me 0.1. And then I'm going to multiply by 10 plus 2x. And then I have plus 0.05x equals 9. I'm going to multiply that 0.1 in. When I multiply the 0.1 in, I should get 1 plus 0.2x plus 0.05x equals 9. I can collect my like terms. I have 1 plus 0.25x equals 9. I'm going to move the 1 over by subtracting 1. That means I have 0.25x equals 8. I'm going to reorganize my work a little bit. I'm just going to put it over here. So I have 0.25x equals 8. If I wanted to solve that, I divide both sides by 0.25. That gives me an answer of x equals, I think it's 32, but I'm going to make sure. Divide by 0.25. Yeah, it is 32. That means I have 32 nickels. If I want to figure out how many dimes I have, I take this solution and I substitute it all the way back into this first one right here. That gives me y equals 10 plus 2. Instead of x, I put 32 because I now know that x equals 32. If I calculate that, that means y equals 10 plus 64. That means y equals 74. So the number of dimes I have is 74. And there's my answer right there. Beautiful. There's one left. Give it a shot. It's hard because it tells you the total number of coins this time, not the total value. Well, it tells you the total number of coins and the total value. But give it a shot. See if you can set up the equations. I'll pause so you can pause too and then try that out. Awesome. To set up this equation, the first question says a number contains 140 dimes and nickels. I don't know which one's which, so I'm going to say x is nickels. I'm going to say y is the number of dimes I have. If there's 140 of them, that means if I was to add the number of dimes and the number of nickels, I should get 140. The second sentence, the total is 1115. We've done these totals a few times now. So that means if I do 0.05 times the number of nickels plus 0.1 times the number of dimes, which is y, it should equal $11.15. Beautiful. Looking at this, if I wanted to try to solve this right now, I have a problem that I have not run into yet. So that problem is that I don't have a letter by itself. In these previous examples, you'll notice that I always started with an equation where I had one letter by itself already. In this case, it's up here, right? Y was equal to 10 plus 2x. If I look up here, x was equal to y plus 5. If I look up here, I started with 2y equals x. I always knew what one of the letters was. This question doesn't have that. So what I need to do is actually rearrange this first question so that x is by itself. So I now have x equals 140 minus y. And then I can do my substitution. So if this x is equal to 140 minus y, then this x should equal 140 minus y. So I'm going to substitute 140 minus y into there. When I do that, I use brackets. So this becomes 0.05. And then in brackets, 140 minus y. Then I have plus 0.1y equals 11.15. If I multiply the 0.05 into the brackets, 140 times 0.05 should give you 7. So I have 7 minus 0.05y plus 0.1y equals $11.15. After I multiplied into the brackets, I had some like terms. I would like to combine those like terms. So I now have 7, and it should come up to be plus 0.05y. Right, so if you add those numbers together, negative 0.05 plus 0.1, negative 0.05 plus 1. Oh, geez. Oh, plus 0.1. I have to do it again because I don't trust myself. Minus 0.1. Oh, see, I got that wrong. No, I did not. I told you my brain is not working today. Plus 0.1 is 0.05. Yeah, I had it right. Equals 11.15. I then want to solve for y, so I'm going to subtract 7 from both sides. 11.15 minus 7 should give me 4.15. So 0.05y equals 4.15. And I divide both sides by 0.05. That gives me y equals 83. That means the number of dimes I have is 83. If I wanted to figure out the number of nickels I had, which is x, I take that answer and I substitute it back into one of my original equations up there. So I now have x equals 140 minus 83. When I do 140 minus 83, I get 57. That means the number of nickels I have is 57. And that's my final answer. Okay, we're almost there. Again, this is a long lesson. We have 1, 2, 3, 4, 5 more questions to go. So it might be smart to take another break just because this has been going on for a long time. So go take a break, get a snack, do something fun. Social distance yourself from others, though. Don't go and have a party or something like that. Just go take a quick break. Walk around the house, something fun, something to get your mind off math so that you're fresh for these next questions. Okay, solving this. We're going to do some shape questions now. So this one says the length of a rectangle is 3 times the width. The perimeter is 96. Find the dimensions of the rectangle. Again, each sentence should be creating an equation. So if I read this first sentence, it says the length of a rectangle is 3 times the width. Length is where I'm starting. So length, I'm going to say is L. Is means equals. 3 times the width would be 3W. The second equation is going to create my second thing. So it says the perimeter is 96. Just for the record, perimeter equals 2 lengths plus 2 widths. Right? That's adding the outside edges. So when it says the perimeter is 96, that means if you had 2 lengths plus 2 widths, it would equal 96. Gorgeous. We've done perimeter questions before like this, so this shouldn't be too crazy new. We now can solve by substituting. If one length equals 3W, that means this length over here should also equal 3W. So I'm going to substitute that in. That'll give me 2 times 3W plus 2W equals 96. I'm going to multiply that 2 in, so I have 6W plus 2W equals 96. If I add those like terms, that means 8W equals 96. If I do 96 divided by 8, I get that the width equals 12. To figure out the length, I take that width and I substitute it in to my length equation. So length equals 3 times 12. Which is 36. So this rectangle is 36 by 12. Awesome. Next example. We're going to read it again. So actually, you could probably try this one on your own. So if you want to pause and try it on your own, give it a shot. First equation is going to give me my first sentence. The width of a rectangle is, that means width is 12 less than the length. That means you would take the length and subtract 12. The second equation says the perimeter is 156. Perimeter is 2 length plus 2 width. That means 2 length plus 2 width equals 156. Again, I want to substitute that in for width. That means I now have 2 length plus 2, and then in brackets, L minus 12 equals 156. If I multiply that 2 in, that gives me 2L plus 2L minus 24 equals 156. Collect my like terms. That means I have 4L minus 24 equals 156. I'm going to add 24 to both sides. I have 4L equals 180. If I go 180 divided by 4, I figure out the length of my rectangle is 45. I could then figure out the width by taking my length and substituting it back into my original equation. So I have width is 45 minus 12. My width is 33. Gorgeous. Rate problems. Rate problems are something new to us. So we'll talk about different strategies on how to do rate problems. The way that we do these, for the most part, is by using a general formula. So our general formula that we do for these rate problems, and it's anytime there's like a job. So if you look, like the first question, the job is filling a water tank with a hose. The second question, the job is cleaning a restaurant. The third question is, again, hoses with swimming pools. We're going to use a general equation to solve these jobs. So the way it works is that you're going to take the time together to do the job and divide it by the individual time for each thing. And you're going to do that twice because you're going to have two different things working together. In this case, it's two hoses. So we would have time together on the top divided by the second individual time. That's the first individual. This is the second individual. And if you do that, what you're figuring out is how much work each individual thing is doing. And if you added those two things together, it should always equal one job done. So our general equation is that if you go time together divided by individual time plus time together divided by individual time, it will always equal 1. The way that works in a question like this, it says Julio can fill a water tank in 4 minutes using a large hose. Okay, 4 minutes using a large hose, that's an individual time. That's my first individual time. He takes 6 minutes using a smaller hose. That's my second individual time. How long will he take if he uses both hoses? That's my time together. If we don't know it, because it said how long, we call it X. So to set this equation up, I would have time together is X divided by an individual time. The first individual time was 4 minutes. Plus time together on the top, time together is X, divided by individual time. My second individual time was 6 minutes. Should always equal one job done. This is a question that's very similar to something in 6.5, so where we have multiple fractions. The way we get rid of fractions, if you don't remember, is we try to find a number that 4 and 6 could both divide into. Both of those numbers could divide into 12. So we're going to have to multiply everything by 12, including this 1 over 1 over here. Then what we do is we go 12 times x divided by 4. The 12 and the 4 can actually divide to become 3x. And the next one, I have 12 divided by 6 will become 2. And then the x will still be the x. On the right-hand side, 1 times 12 divided by 1 will just be 12. And now I've gotten rid of my fractions. If you don't remember how to do that, go to lesson 6.5. I think it was 6.5. And that'll show you how to solve fraction equations like that. I then have like terms, so I have 5x equals 12. If I divide both sides by 5, I get x equals, should be 2.4, but I don't trust myself today. It is 2.4. That means it takes 2.4 minutes to do the job together. Awesome. We'll look at B. So it says, after the restaurant closes, Roberto takes 2 hours to clean it. Okay, that's an individual time. And then we're going to say it's our first individual time. Bill is new to the job and takes 4 hours. That is going to be my second individual time. How long would it take them if they work together? How long would it take them to work together? That is our time together. We call it X because we didn't know what it was. If we use our formula from the question above, if you go individual time, so individual time, first one is 2. Oh, sorry. Time together on the top. So first fraction, time together goes on the top. So we have X divided by individual time on the bottom. The first individual time is Roberto. It was 2 hours. Plus, Bill is new to the job. It takes him 4 hours. So we put the time together on the top, which is X, and then we divide it by 4 hours. And I'm always using this formula to equal one job done. And it is 1 divided by 1 if you want to make it a fraction. I then can solve this equation. The setup's the hard part, right? Solving it is a basic 6.5 question. I'm going to multiply both sides by 4. Or sorry, not both sides. I'm going to multiply all the equations by 4 because all the denominators could divide into 4. This will become 2x plus x equals 4. That means 3x equals 4. Divide both sides by 3. That means x equals 1.3 repeated hours. 1.3 repeated hours. Awesome. The last question here, we have 3 hoses are filling a pool. So now instead of having 2 fractions, we're actually have 3 fractions. We're going to have time together divided by first individual time, plus time together divided by second individual time, plus time together divided by third individual time will equal one job done. Our individual times are 8, 12, and 24. So that means we're going to have x divided by 8 plus x divided by 12 plus x divided by 24 should equal one job done. To get rid of those denominators, I have to find a number that they can all divide into. All those denominators can divide into 24. So I'm going to multiply all by 24. If I do that, I can focus in on the numerator and denominator. So 24 divided by 8 is 3x. Plus 24 divided by 12 is 2x. Plus 24 divided by 24 is just x. And that equals, oh, I almost made the biggest mistake. I forgot to multiply this 1 by 24. Equals 24. Collect your like terms. That's 6x equals 24. Divide both sides by 6. And you get that their time together would be 4 hours. Wonderful. I know that was a long lesson. Thank you for fighting through it and bearing with me. Hopefully you took some breaks to keep your brain fresh. It was also a very hard and challenging lesson. If you got frustrated, I understand. Maybe take a break, come back and watch it again, and then try to do the practice booklet while you're watching the video, and maybe that'll help. We did have different types of questions, so try to figure out the rate problems in your practice, and then watch the shape problems when you're doing the practice. Watch the money problems when you're doing the practice. You get it, right? So that way, when you're practicing, you're actually watching the right videos to help you with your practice. Best of luck. Stay safe out there. Take care. If you need anything, reach out to somebody. Reach out to myself. You can always contact me through email. Reach out to other teachers. Reach out to your parents. Reach out to your friends. Reach out to somebody if you need something. Take care. Miss you all. Best of luck.